We are looking at functions for additional maths, and a catalogue of essential functions are used in mathematical modelling. Today we'll be looking at exponential functions, inverse and composite ideas, the range, and a few sketches as well. So here we have our first sketch, and we have an exponential function. So we can see that we have a plus 1, so it's raised up 1 on the y-axis. So 3 to the 2x plus 1 is greater than 1. So the range means the output, so on the y-axis. And our second function is a linear function, x plus 1. So like any of those from negative infinity to positive infinity, you are dealing with all real numbers. So there's no restrictions on the range for any linear functions. Part 2, we just rewritten that there, so g squared is g times g, and just plug in your numbers. So it's a little bit of substitution there. Same with the next one as well. So 1 plus 1 is 2. Next up, hence. So now hence, if you ever see hence, it means something's carrying on from an earlier part of the question. So we already have g squared of 0, so we're going to just plug that in there. So f times that will be our new answer. So f with 2 is 3 to the e, as 3 to the 2 times 2 plus 1. And of course that's 3e to the 4 plus 1. So the third part done. In the next question now, it's a little bit different. We have to do some sketches. So we have to sketch y is equal to f of x, and we have to sketch the inverse of that. And we also have to state intercepts and asymptotes as well. So let's start with our first function that we were given. We want to find the intercept. So we find f0, it'll be 3e to the 2 times 0 plus our 1, which is 3 plus 1, so that would be 4. So it crosses the y-axis at 4. So now let's start drawing this. And again, we have an asymptote at y equals 1. And I'll draw it as best I can, easier by hand. And our second function is the inverse of that. So now you know, if you're dealing with inverses, we have the y equals x middle ground, we'll say. So at the y-axis it was 4, at the x-axis it'll be the same, and we have the same asymptote going the other way, where x equals 1. So redrawing that, that should look in some way symmetrical. So we should have symmetry of y is equal to x. We have our inverse and we have our asymptotes as well. And that was part 4 for that question. In our second question, we also have an exponential function and a linear function again. So we have to find the range for f and g. So let's do a little sketches here. So you'll have plus 3, so it goes up from that point. So just think about that in terms of the range. It should go, well, it should grow up basically more than 3. So f is greater than 3. And in terms of just x, like x is going to minus infinity, so e to the x is going towards 0, never quite reaches there, but it's going that way in terms of that. So f is greater than 3. And for g, of course, again, it's all real numbers we're dealing with here. So any linear function, there's no restrictions. The range is from minus infinity to infinity. And my graphs are not necessary in terms of the answer, but just demonstrating that so that you can see it more clearly. So g is an element of all real numbers. On to the next part. Find the exact solution for this. So we've got an inverse equal to the derivative of g. Okay, so 3 plus e to the x is equal to y, or y is equal to 3 plus e to the x. So e to the x is equal to y minus 3. One of our rules of exponentials and inverses, of course, in terms of natural logarithm or logarithms, is x is equal to the ln of y minus 3. And so just rearrange that then with ln x minus 3 in brackets. So ln or natural logarithm, or ln. G to the prime of x is equal to 9. That should be straightforward. And just equate them there, and you'll get x is equal to e to the 9 plus 3. And that should be straightforward. You should know your differentiation from GCSE as well anyway. Okay, find the solution of g squared of x. We've come across this idea already. So g times g to the x is equal to 112. Just plug that in. So 9 times bracket 9x minus 5 close bracket minus the 5 is equal to 112. And simplify from there. It's just normal algebraic skills, as you know already. So 81x is equal to 162. And of course, a nice easy x is equal to 2.